So we are really, really happy to have you with us today. So Sarah and Sébastien will be showing us how to ensure that the models we build solve high-value business problems using MLOps. Now on the technical details, if you have questions throughout the session, you can write them in the chat. And at the end, I will enable the audio and video, so you will be able to ask your questions directly to the speakers. So thanks again, Sarah and Sébastien. I will end it to you for your presentation.
Thanks a lot, Gabrielle. So I'm very happy to be here today with you. I'm with my colleague, Sébastien. Sébastien is the real specialist in the MLOps. So I will start the workshop, but Sébastien is the great person for that subject. Sébastien, bonjour à tous, il y a des francophones aussi. N'hésitez pas à poser, la présentation sera en anglais, mais n'hésitez pas à poser vos questions en français si, par exemple, vous le souhaitez. Sébastien, est-ce que tu veux présenter ton écran? So as Gabrielle said, we are from Videns Analytics. We work for a company, a young company of 4 years old now, that I have founded, and I'm the CEO. We are specialized in the deployment and development and deployment of artificial intelligence solutions. So it's the subject for today. Sébastien, you can switch the page. And the other one. Thanks. And we have some certifications, and we are so proud of being here, a company women-owned, and we are a team of 40 employees and collaborators. So it's good. Sébastien, you can switch. What we do 4 things, and we have 3 axes in service. We accompany some companies in strategic support in data valorization and artificial intelligence. So it's for the thinking of data valorization, data exploitation. So, for example, we work with our clients for doing a roadmap or some strategic things about data. We develop and deploy some artificial intelligence solutions. So here it's very technical and end-to-end solution. And we do some training, in-company training on different subjects of data and artificial intelligence. It's more detail, so I can continue. And for that workshop, we will have four subjects. So the first one is what is MLOps? The second one, the DevOps versus MLOps. What is the difference, and how I can explain the difference, and when we talk about DevOps and when we talk about MLOps, after the 3 stages of MLOps capacity, and for the end, Sébastien will present the essentials of that field. Data science and artificial intelligence are a large cycle. So it's a large subject that have many steps and many important parts. So it's important to well understand the whole cycle of data science or artificial intelligence process development. So at the beginning, we have the business need, we have the objective of the company, for example, the business objective, and it's important to well understand that business need. So after the strategy will be developed on that understanding of the well understanding of the business need. So after we have a step for data collection and pre-processing, it's an important part because it takes time. Sébastien,
Yeah.
So sometimes the data is not available, sometimes the data is not clean. So we have to think about what we have to do on data to be able to develop algorithm after. So it's an important and a large part of a project. We have after the algorithms development, we have the deployment part, and it's an important part too, because it's the part that make the solution able to work. So before that, we don't have a solution. And after, we have the monitoring, maintenance, and improvement part, and a so important part too. And it's linked with the subject today. So I can share the microphone at Sébastien to continue on that subject.
Thank you, Sarah. So yes, I really like that slide also because it ties in nicely with what comes next. And, you know, it's what you're seeing right now on the screen. All these steps are part of MLOps, and they're part of DevOps also, in fact. Of course, today we're talking about MLOps and the difference between like DevOps, MLOps, and all these buzzwords that we hear a lot. And you'll see at the end, it's not that complicated. It's not a cookbook, a kind of workshop. I'm not going to give you like the specific tools and like the specific code snippets that you need and stuff like that. That doesn't work. I mean, it always depends on what you're dealing with, like what kind of data, what's the project about, your client, you know, what platform is she using, you know, is it on-premise, cloud, whatever, what's the environment like? So it's more about like fundamental principles and understanding like what's going on with MLOps, what's so important that you have to manage in a project when you want to do MLOps. And in fact, I'll give it to you right away from the start. You're probably doing MLOps and you don't even know it. We always think of MLOps as something like, you know, very complex and a lot of tools and automation and stuff like that, which is true. I mean, MLOps can look like that, but MLOps can look quite different also. And you'll see in the different stages and stuff like that. But MLOps, when you use MLOps or DevOps, these parts, and especially MLOps, because DevOps, you don't really necessarily work with the data collection and pre-processing, because DevOps is software, like software oriented. MLOps goes beyond that, and that's what we'll see, and how we can put together or take the lessons learned from DevOps and use it for managing artificial intelligence projects, data science, machine learning, and such. So what is MLOps? And you know, that's the best way I can think of it. And that's how we practice it at Videns. It's really like at the crossroad from machine learning. So we have data scientists like working on their models, finding, you know, a solution for our clients to add value to their business. And to make it work, actually, even when you develop it, you need data engineering. Like Sarah said, it's almost cliche right now to say it, but still it's true. Data is not always available, and it's not in the right format. And she said it's, I like when you said, sometimes it's not clean. I would say most of the time it's not clean or in the right format. And so to train your model and to test it and then to make predictions, data need to be engineered. It needs to be collected, pre-processed, made available at the right time, and such. So data engineering is very, very important. I mean,
and maybe, Sébastien, we have to review that slide and enlarge the data engineering circle. Yeah,
I know it's such an important phase because it's very important. It affects, how the data scientists can work, and I mean how fast they can work. They need data, and they need good data. And if they have to spend a lot of time working on the data, they're not doing what they're good at, which is data science. And so you need someone in charge of that, or part of your team needs to be focused on only the data engineering. And then that needs to be incorporated together. There needs to be a workflow, a planned workflow between the data engineering and the machine learning. So when you get these two pieces together, then the data science part, so to speak, is good. It's okay, it works. But you also need DevOps, okay? Because there's code involved. And like Sarah said, the deployment part is such an important part also. You can have the best model in the world and have like all your data engineering pipeline in place and data's flowing and your model's okay. But if people can't make requests to it, or if they can make requests to it, but your solution is overwhelmed because it wasn't designed well, or you need to modify something, but it takes months, years to retrain and redeploy and modify. And if you modify something and you push it to production, it breaks and you don't know why, and it's a nightmare. Believe me, you don't want to be in that situation. So DevOps is definitely there, and that's why we call it MLOps, is applying lessons learned from DevOps to MLOps, because basically in the software industry, they realized that, to scale the solutions that they were deploying, the traditional way of doing it wasn't working anymore. You had the development teams and you had the operation team, the IT team. And these two teams were traditionally working together, talking together. The development teams was developing something and throwing it over the wall, so to speak, to the operation team, and it was a mess, okay? And the same thing happens with machine learning. If a data scientist just throws a model on me and saying, Seb, put it into production, we'll have a problem. I need to know more than that. I need to talk with you. I need to know what's going on. I need to understand data flow. All that needs to ties together. And that's where MLOps comes in. Because again, DevOps is okay from a software perspective.
Yes, it's not the same thing.
Yeah,
the deployment of a software is
it's one thing.
Yeah.
But and that's what we realize. Okay, we apply DevOps principles to developing the code around the solution, but the code, the machine learning code itself, and the models and the data, these principles weren't applied to that part of the solution, and that was a problem. And that's where the idea of MLOps appeared. Why not use these principles and just apply them to machine learning? And I talk about DevOps a lot, but just to give you a quick definition, I already said, it's, you put development and operations together, basically, just putting these people in the same room working together. And, but again, it's not just tools. A lot of time we think about DevOps and MLOps and stuff like that, just like tools. Are you using Jenkins, Ansible, Terraform for your infrastructure as code? And what's your pipeline made with? It's not that. That's a tool.
And tools are very changing.
Exactly.
Yeah.
So I'm always
you never thought the same
yeah
thing.
Exactly. Yeah. So of course I have like anybody in any trade, I have like my preferred tools, but tools aren't that important. you got to get the principles right, and you have to get the culture right. When we talk about business culture and practices, that's super important, even more important than the tools. Even if you have tools, if your organization is not structured to let people work in a way that make DevOps possible, then all the tools in the world and all the money you can throw at it won't help you. So that's very important. So it's just really the idea that you break the silos between these teams, you let them collaborate, you let them work together, and you make them responsible for the solution. It's not just development doing something and then throwing it at operation and saying, okay, it's not my problem anymore. No, at Videns, the data scientists and the software development and like the operation, like me, we all work together. And if something doesn't work into production, it's everybody's problem, not just my problem. It's everybody's problem. So that's how you have to think.
And it's a big learning, because when we are at school, we don't learn how to develop our code and our algorithms and our data transformation pipeline to be able to for deployment.
Exactly. Yeah, it's a very good point. Yeah, and that's why DevOps and MLOps, especially MLOps, is so important, because like Sarah said, data scientists, they're not software engineers. So the way the code is developed is sometimes suboptimal. So you have to rework it, or you have to really like rework it to make it more maintainable and stuff like that. But if you just work in silos, when it gets to the point where you realize that you have to rework it, then it's a lot of rework. When you work together, then you can spot it right away. And, then also, it gives you a heads up for a deployment. Like Sarah said, deploying a model, it's not the same thing as deploying software. So some things I have to know in advance to make it easier to deploy. And that's where working as a team in MLOps really helps. Again, a little definition for data engineering, practice of designing and building systems. Yes?
Sébastien, it's because we have a question from Gabrielle. So Gabrielle asked, when do you recommend to start working with these people? Right at the beginning of the project, in the modeling part? So
as soon as possible. Definitely. When the project starts, you should really get these people in the same room and working on the solution together from the start. Yep.
And I can add that it's important to give us feedback from the MLOps specialists to data scientists to be sure that the next time will be better, and
feedback on all levels, not just human levels, but MLOps and DevOps have this idea that like fast feedback is very, very important, and that's why we test from the start. And at every time we push code, we test. Every time we incorporate new data, we test, because we want feedback. And we want to push features as soon as possible, because we want feedback from the client, from the user, as soon as possible. So if something has to be modified, we want to know it as fast as possible. And that's why you need all these people together as soon as possible. So then it makes it a lot easier to modify the solution as you go also, because of course we always like to have like a big nice plan in advance, but plans don't usually survive the field of battle that is data science. So it gets messy, and if you have the right process and right people, then you can work through it. Data engineering, just collecting, storing, and analyzing your data at scale. That's the important part, at scale. The amount of, even if we're not talking about like big data, just the amount of data and how it will be collected, analyzed, and fed to the model, just for training, for testing, and in real life. That needs to be done, and in a robust way. Because again, if you don't have data, even if you train the model, if the pipeline is not in place after that to retrain the model, or if you have like live streaming of data and stuff like that, you need to be able to manage that kind of infrastructure at scale. So the data engineering part's super important. And of course, we're talking about MLOps. And I'm not the data scientist on the team, so I thought it was kind of important also because maybe some of you don't know about, really what it is. We hear about it a lot. What's the difference between data science, machine learning, and all these words. It's defined as a discipline of artificial intelligence, AI, that provides machine the ability to automatically learn from data and past experiences to identify patterns and make predictions with minimal human intervention. And that's where MLOps is very important, because in MLOps, we try to automate as much as possible. So your model should be able to retrain and learn on good data by itself with minimal human intervention. So how do you manage to do that? That's always the question. And of course, there's tools, but I think like the key getaway is a lot of planning, a lot of sitting there with your team and saying, how can we, like, what are the pieces, what are the steps that are we doing manually right now that are working? And then from that, how can we make human not necessary for these steps to happen? Okay, so that would be like basically what we're trying to achieve with MLOps. And we're talking about different bubbles. Data engineering is super important versus the rest. And I also like that slide because it gives a sense of proportion, between what's going on when you do machine learning projects. Sometimes the big perception that everybody has is that little dark gray square, which is ML code. In most people's mind, that would take like half of what you're seeing right now, and the rest is just it's around it. We sprinkle a little bit of data collection, automation, and stuff like that. But the most important part is ML code. And of course, it is important because without that code, then we don't have a solution. But without the rest, still you don't have a solution, and you can't maintain that solution also in time and in quality. So data collection, verification, is it good data? What's happening? Like the data we get now, is it as good as it was like 2, 3 months, 6 months ago? Configuration, you're running your stuff on machines somewhere. Even if you go serverless, there's a server somewhere and the service has to be configured. So how do you keep track on these? You redeploy, is it the same configuration? What's the effect on the results if you don't manage that? Testing and debugging, of course. Again, how do you manage your testing and your debugging? Do you have like clear messages? Do you have tools to keep track of that? How do you manage that? Resource management, your infrastructure. You have to manage it and you have to serve it. Do you do infrastructure as code to be able to replicate how you serve and all that? But that's all code, infrastructure as code. So all these, and I won't go through all of it, but there's code everywhere in these squares. So the quantity of code, relative to the ML code itself, it's huge what's around it. And MLOps really needs to manage all the code, not just the ML code, but everything that goes around it to make it sustainable and scalable. Okay. So if you do like a comparison between DevOps and MLOps, the big one is this. Machine learning is not just code, it's code plus data. And that's really the giveaway, like the important part. It's when you think about MLOps compared to DevOps, it's only about code, it's software, but MLOps, it's how do we manage code as in DevOps, but also how can we manage the data that we have for our solution as in DevOps with these same principles. So code plus data, how do we manage it? And just to give you like an image, you have like two pipelines in MLOps. Basically, you have the code pipeline, which you would get normally in any software project. You know, you have the code, and you have CI/CD, continuous integration and continuous deployment. And you know, you just manage your code, you automate tests, you deploy and stuff like that. You know, your code goes to the training, serving, predictions. But you see, you have also like that other pipeline that's not there usually in DevOps that you find in MLOps. And it's all about the data, you know, the data engineering part, sorry. You know, that pipeline, all the steps, the cleaning, the pre-processing, the validation, that needs to be managed also, automated, documented, monitored, the training of the models, the retraining of the model. If there's if there's a problem, if data quality is an issue, then your model may give, wrong or lesser quality prediction per se. That's the green pipeline taking care of that. So MLOps, the added layer of complexity is it's not just managing code, it's managing the data that goes with the code to serve your solution. Also, difference, between these two approaches. MLOps is a lot more experimental in nature, meaning that, if you develop software, pretty much what you have to do, the features that are expected and how it's supposed to behave and stuff like that. If you do machine learning, data science projects, like I said, there will be code that will go around it to make it available, and that is easily managed. The part that is a lot more experimental, and Sarah can talk a lot about it, I'm sure, is how experimental, and it's an exploration of data to find the right solution. And how do you keep track of that also? How do you know you didn't try that algorithm or that transformation on data? And so it's a lot tougher to manage that part, and it's again an added layer of complexity. And it's a good practice, when we work with data scientists, just using version control basically on your models, some things that data scientists don't have the the habit to do. But just to make sure that how do you keep track of all these experiments that you did from a machine learning point of view. And so that's something quite different also for us, operation and solution architects and stuff like that, just to manage that complexity in the project itself, to make sure that the value is delivered with that part, and yeah, using maximizing code reusability also, because it's such an experimental phase that, again, some code that was working isn't working with another version of the model and stuff like that. And so you really have to get a good process in place. There's not like one good process. Many processes, many way of working can manage to achieve that. Again, you just have to get the right people in the same place and having that reflection. How are we going to manage it? And, and not reinventing the wheel, just looking at tools or processes that already exist, but making it your own and really using it. You have to be very disciplined for it to work. It's not just, when you think about it, you do it. No, you need to do it and enforce it, especially at first. But
sorry.
Yes, no, that's okay.
When we work on a regular software development and deployment project, we can work with a cahier des charges, a charge book. I don't know if it's the good word, but and we can realize the project with that. But in data science project, the experimental part is so important, and
Yeah.
it's the reason why we can't use the book charge like in a regular project, software project. Yes.
Yeah. So the development phase in MLOps is quite different than in traditional DevOps.
Yeah.
And that, for me, like the team composition is so important. I think MLOps is not really a technical problem, basically. Okay, it's very much about culture and structure and the organization, like how it's built, how it works. So yeah, I think the human factor is like the most important one in MLOps. It's not really about tooling. Like I said, you need like different sets of skills. You need the data scientist or machine learning engineer. You need your DevOps engineer, data engineer. And it's kind of tough to find like one person who does all that. It exists. I know some of them. I'm always impressed to talk with them because you learn so much. They have such a nice overview of all these fields and how they work together. But they're rare. So I mean, you really need to focus on building the team that will deliver the value for you. Of course, like DevOps and data engineer can be the same person, or maybe your data scientist is good at data engineering also. But you just need to clearly identify these capabilities within your team and making sure they're there and that someone does it. That's very important. So yeah, they have to work together. So team composition really tops any tooling or platform or gizmo that you can buy right now. Invest in human resources if you want to put MLOps in place, and not so much in tooling. Another part that is quite different also is testing. Of course, it's a lot more involved and complex to test a machine learning system than just software. Testing a website or an app or something, where that if you give X, you'll get Z. That's easily done now with the expertise and the knowledge and the tools that we have. But for MLOps, there's a whole lot more testing going on, because of course you have like traditional unit and integration testing, but like you can see, you have like data validation, that needs to be tested also. The new data that I'm throwing at the solution, is it still valid? And on which criteria do I use to know if it's valid or not? Have I thought about all the possible variables that will be thrown at it, and all the possible formats, all that stuff? That's a whole nother level of testing. You test also for your model quality, maybe through time, especially if it's retrained regularly on fresh data. You have to evaluate, is it still a good model, and how do you go about that? So again, if you want to automate that, it's a whole lot of planning. It's good. I highly encourage it, but it's a lot of planning, and there's no tool that will do it just out of the box for you easily. And also the model validation. So you trained it, it works as expected. Does it deliver value really? How do you validate that? Again, which criteria do you use, and the frequency of testing and all that stuff? It's a lot more complex than just plain software. So like I said, it's not just about testing. Anybody can write tests for software and for an MLOps pipeline, but do you have the right type of test? That's the real question. I can test all day, maybe it doesn't mean anything, or it's superficial. Even if I have like 100% coverage, Yeah, I cover everything, but to which depth? And especially for the data part, that's the most important question. So that's to be kept in mind, and test as early as possible. If you try to write the whole testing pipeline at the end of it, good luck. I mean, I sympathize with you. It will be tough. I wouldn't want to be in your place. So as soon as possible, take the habit of just incrementally build on, what you started to do from scratch, from like day one. And deployment. You see, there's a lot of stuff because that's usually where I play a big role. But yeah, so deployment is also quite different in traditional software than a data science MLOps project, because it can be quite simple. In MLOps, I say that isn't as simple as deploying an offline. Actually, it can be. If that's your level, it is. We all start from there. The model is trained offline. The data scientists say, okay, it's ready. Just build an API around it and deploy it on a server, and that can be as easy as that. But if you really want to if you want to go to the next stage of MLOps and really scale, then you need to be able to do that fast and automated. And why do we talk about automation so much? Because humans are prone to make errors, especially for repetitive tasks that demand a lot of concentration. And deploying is exactly that. You have to configure the machine, the server, the pipelines, and everything. And then if something gets retrained, then you need to clone code or pull a Docker image, whatever. All these steps, they take time, and if you do it manually, it's error prone. So I would say we all start manually, but then build on it. Can you do it manually? I said yes, of course, but only within a very specific scope, especially at the beginning of the project. Yeah, of course, you're testing, you're prototyping, you can do it manually. But if you're scaling up and you're going like industrial scale production of your model, if you do it manually, like I said, you'll experience extreme level of stress, frustration, and sleep deprivation. Believe me, you don't want to do all that manually. If you make no mistake, it will take all of your time and it will be quite stressful. And if you make mistakes, which will happen, then you'll hate your job and your life in general. Okay, so you don't go there. Automation is the name of the game in that part. And so we talk a lot about CI and CD, continuous integration and deployment. And these words, these concepts are quite known right now. So integration, you just test and validate, these components that you want to integrate to your solution, and you just do it like continuously. As soon as something new is there, you can integrate it. And that is not only for software anymore, but for data schemas, models, stuff like that. Continuous deployment, if it's ready, if it's integrated, why not put into production right away? Of course, you need tests to be sure that it's working, but if something is good, it's working and passes all the tests, there's no reason to keep it there for another couple of months. I mean, there can be reasons, the way the organization is structured, dependencies and stuff like that, but conceptually, we have the tools and the means and the processes to make it happen. Some organizations deploy every day, multiple times a day or every week, but it's not a matter of months anymore necessarily. So that's important. New concepts that comes with MLOps, CT, continuous testing. Okay, because we have these two pipelines, and one of them, the data, is continuously refreshed, and you have new data and you don't know what's coming in necessarily. You have to test continuously these data feeds, these data transformation, and the whole thing around it. So that would be like the new player for the pipeline of MLOps in deployment. And of course, monitoring, so important also. Not only monitoring the code performance that we can measure, is it optimal? How fast is the response coming from the API, and is the code, behaving as expected and stuff like that. So that is well established. But also the model performance. So that's the new player. Not only do you monitor the code, but now you need to monitor the model. And of course, basically the tools are pretty much the same. You just have to adapt to what you're monitoring. And just to be able to, I think like the real challenge here is to determine, to identify, what are the thresholds? What are the criterias from which I will decide if it's still a good performance or not? What will be the trigger? So you see, again, it's not really like a tool problem. It's really more about, you have to think it through. You have to understand really what you're trying to do. The tooling, then it's the easy part. If a data scientist is telling me, if I reach like that level on, that criteria, that variable in the pipeline, I want to automatically trigger a retraining of the model. For me, that's easy. The tough part for me, because I'm not a data scientist, would be, well, what's the variable? What's the, what's the key that will decide, if it's good or if it's not good. And so I think that's in MLOps, that's really important, identifying, when a model is not a good model anymore. And can we measure that easily in production continuously? So that's the important part in monitoring in MLOps. Like I said, it's easy to control code quality most of the time. There's always errors, of course. We try to eliminate as much as possible, but controlling data quality, the new meaningful data that comes in, again, some projects you get live streaming from different sources of data, and something new may appear, and maybe your first reaction is to just discard it, but maybe it's new meaningful data. How do you manage that just to make sure that you're not throwing away value? Do you have room for that? How can you manage that in the pipeline? That's a whole other business than just monitoring quality, code quality. Again, beware the model drift. It happens a lot. Your model is good, and then new data, it's retrained, and then whoops, it's not the same anymore, and it's important to catch it. That's one thing. But I think in MLOps, again, it's not necessarily a technical problem, but the most important part is to understand why it happened. I can raise a flag or trigger saying, the model is at 82% accuracy right now. But why? That's the real question. And I think in MLOps, that would be where your focus need to be. It's not just to identify, a model drift, but you have to monitor information that would allow you to easily identify how it happened.
And to think about that subject before deploying, and before, it's a great mental exercise, because you have to plan what can arrive after in the future.
And I think something as basic as just good logging is so important, because you have to think a lot about, like Sarah said, about what might happen. But we always have a saying, me and one of my colleagues, because it happened so many times. And for us, the definition of a nightmare or hell is basically user input. If you just leave the user to input anything without constraints, then all hell breaks loose. Okay.
We
And
can't trust the user, huh?
no, you can't. You absolutely can't. And it's not, I don't think it's never like bad intentions. It's just, people maybe they didn't think that it would cause that problem, or maybe the graphical interface wasn't clear enough, whatever, all reasons are good. And even just like processes, business processes, and it happened, and you'll see it a little later, a couple of slides. I have like something that happened that, made us realize that, it's important to know that the model, the performance, let's say, goes down, but you have to understand why. Because if you don't have good logging and you didn't think about that this might happen, then your logging will save your life, because then you can go through, even if it's tedious, at least you'll have something to work with. So monitoring and logging is super, 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 super important, especially for the data part of MLOps. So in brief, if you just go like through these steps that goes into like an MLOps project, you'll see that some steps, like the terms that goes for like serving, monitoring, they can go for software, but in MLOps, we really focus on, the model itself, applying these principles to the model itself. So data gathering, again, that's your first step. You need data. If you don't have data, then you don't have a project. Okay, even if you have good ideas, you need the data to back it up and train the model and everything. And you need to analyze the data, of course. And if it proves interesting, then you probably have to transform it and prepare it in a way that will be usable for the data scientists. And then you go into your exploratory phase, of training, and you develop and you test and all that stuff. And when you think you have something good, you validate it. And then you serve it, meaning you deploy it. And monitoring, and of course, that we didn't talk about a lot, but retraining. And I think that's something of a sensitive point for a lot of people, even for data scientists. Automatically retraining a model is not something that is easy to put in place or easy to think through, because it's hard to predict every possible outcome and test for it. And so automatically retraining a model based on a trigger, we can do it. But that's, again, another level of complexity and planning. But that's something that we try to do as often as possible, especially if the steps are clear and we know exactly how to validate like the value of the retrained model. And these steps are manually done by the data scientist. That's easy. But for some other projects and models, the automatic retraining of the model, that's something that is, I wouldn't say impossible, but it's a lot more difficult. In practice, we talked about principles, but in practice, how do you do that? And in fact, like I said, in practice, and these I didn't invent. I think it's a Google team, but it's used by a lot of different organizations right now. These stages of how do you evaluate where you are on the MLOps scale. And the stage one, like I said, where we all start, is manual process. And it's part of MLOps. If you're managing your data, your models, your testing, and your monitoring and your deployment, but you take in charge all these steps, but you do it manually, it's still MLOps. It's just that you do it all by yourself manually.
Yeah, you have to well understand the whole process of your
exactly. I think every project starts there, because the way I like to explain it is DevOps or MLOps basically is learn to do something well and then automate it. and then learn something else, learn the next step, but you take baby steps. There's part of the process that you're really good at, it's solid, you know how it works. Okay, when you reach that level, automate it, then go to the next step. And you just build incrementally like that. Don't try to do it all at once. Don't try to be a stage 3 from the get-go, day 1, first project, new team, and you want to go to stage 3 right away. No, because you probably don't even understand the steps, the basic steps that will be necessary for your project. If it's the same thing in same team and different projects, but you have like a lot of experience, stuff like that, yeah, stage 2 and stage 3, they're probably reachable because you've managed to master so many basic steps from the stage 1 at that level that you don't need to relearn these steps. But we all start at stage 1. Okay. Stage 2, you automate really like the pipeline automation, and like I just give a little bit of detail here, but you automate the data and the model validation steps, okay, of your production pipeline. Usually the first steps to be automated is the code step. You remember like the 2 pipelines, data and code in MLOps. Well, the code pipeline is usually the first one to be automated because it's easier. But when you get to stage 2, then the data and model validation are also automated, and the retraining of the model also can be triggered by the monitoring steps. And you see, just the retraining, the model in stage 2, it's like, when you should retrain, but you keep the human in the loop before it goes to production. It's retrained, then the data scientist goes and validate it, So, okay, there's a model drift. It has been retrained. Let's see if it's good now. It's not automatic. And your deployment, what you deploy at stage 2, it's not just the model or the code, but the whole pipeline. So the code that goes with the pipeline, the code of the application, the model, the data for the data pipeline, the code for the data pipeline, all of that is what you deploy at that stage, and not just only like code for the application and the model. It's the whole pipeline that is deployed. And when you reach, I wanted to give you a little example. Okay, I'm not running out of time yet, but close. I wanted to give like just a little example for stage 2. It's a project that we've done, and one of the problems that we had was we were supposed to only receive PDFs, and of course we didn't. We received Excel spreadsheets, Word documents, stuff like that. And also it was supposed to be one PDF, one document, a letter or an invoice, but then again, sometimes one PDF was multiple different documents into one file.
100 pages of a few documents.
So we had the model drift, all of a sudden we're training the model and the days were going by and like the accuracy of the model was just going down and we didn't know why. And so we looked at the logging, and because of some conditions and tests and looking at the logging, then we found that. And, when I said, it's very important to have good testing and good logging to understand, not just catch the fact that the performance going down, that's easy, but understanding why it's going down. And, that was just as easy as saying, of course the model is going down because you were supposed to train that model saying, okay, that's an invoice, but when you opened the file, it wasn't an invoice, it was an invoice plus many other documents. So that's an example of stage 2 when you try to automate stuff. And after that, in our pipeline, there was a trigger and a cleaning step of the new data coming in that really enforced the fact that If it wasn't a PDF, then it was just thrown aside. And if it was bigger than which amount of bytes, then it would again be thrown aside. So, you learn these steps, you validate them, and you automate them. Yeah, also another quick example, we have a project with a cement company, and the whole integration pipeline and deployment pipeline is automated with them. And it's all done with GitLab. It's just version control, but then they have like pipeline capabilities, automation capabilities. And we use DR language, and it's an API, and the model is also, and it's deployed on AWS. And the code and the model pipelines are automated with GitLab. Every time a new model is trained, it's validated and pushed and put into production. And also the model can be retrained manually by the users. If some users, like if the user has a new data set, the pipeline accepts the fact, okay, you want to retrain one model, test something new? Yeah, we can do that. And it's all automated. The only thing the user has to do is push his data set, and there's a new model available. So that would be like really like the stage 3 of what we're trying to do. It's everything is automatically retrained, tested, and put into production. So what's really cool about this when you reach that level is that your data scientists really do what they're good at. Okay, they're really just focusing on delivering like good models and working on creating new solutions that are delivering value, and all the other stuff around. Of course, there's a team behind it, putting these processes and tools into place, but it makes it possible to deliver value so much faster and with so much more capacity to serve that solution at scale, and to test different things quickly, and correct and fix things also very, very fast, or do some rollbacks and stuff like that. So that stage 3 makes it even easier to deliver value to your clients or customers. And then just like the big key elements that you have to remember, most of them I talked about. Learn to do one thing well and automate it. That's the basic. You have to do that. Also, harness the power of the cloud. I mean, you can create infrastructure and destroy it like within minutes. Even if you have your own private cloud or on-premise infrastructure, when you're prototyping, when you're like at the first stage of your project, harness the power of the cloud. Validate what you think will be like a good solution, and try these solutions. Of course, we said it a lot. Think things through. Take the time to sit down and plan. I know sometimes it would feel like you're losing time, but you will save so much time down the road. But of course, don't overthink it. Like we said, it's good to have a plan, but plans usually don't survive very far. But you need a plan. Just don't get too attached to it. But yeah, definitely take the time to think things through, and it will help you a lot. Learn the principles, the concepts, and the tools will take care of themselves. That would be like also super important for me. If you have to remember one thing, that would be it. Learn the processes, how to work, the concepts, and then you can apply that to any situation that you will face, any environment you'll work in. And also, question I have a lot of time, custom or end-to-end. If we really want to talk about tools, because people love tools, which ones should you choose? I would say it's really a matter of budget and human capacity, capabilities within your team and stuff like that, and like your vision long term. But again, I would say at first harness the cloud. Even if you want to do something custom, like the three big players, Google, Microsoft Azure, and AWS, they all have tools that would let you prototype fast and test ideas fast. And then if it works, you can, build your custom solution based on what you learn, but don't try it custom from the get-go. Just test stuff, and then you can decide, well, okay, I have a use case, something custom is in order, or you can discover that, there's tools and platforms that these providers have that are like end-to-end solutions for you, and maybe that fits your team and budget and organization. So like, just to tie it in, again, it's not about the tools. Learn the principle, the concepts, and then everything will be a lot easier and clearer for you. And that's it.
Thank you, Sébastien. I'll just enable the like unmute buttons. So if you have questions, you can just unmute yourselves and ask them. Maybe I have one question to start.
Yes.
So when we are in enterprises, or at least where I worked before and where I work right now, we often have the case where we have a lot of data scientists and only a few people like in the MLOps team. So people are not like available to come right at the beginning of the project.
Yeah.
So do you have any recommendation on how to deal with that to make sure, everyone is happy and we're delivering correctly?
Yes. Yeah. It is an issue. Yeah, of course. And, it's something that even myself at Videns, I'm one of the only person that does what I do. And, it's hard to be there for everyone, but it's possible if you prioritize it. And also, there's some stuff that maybe these person are doing that you don't need to be doing. But and sometimes it's okay if they're not there like day one. That's like perfect world. But I would say as soon as possible, at least if the exploratory phase of data science, that's okay if they're not super committed to that part. Just, I'm okay up to that part. I'm okay that, people just send me like emails or texts or informing me, we're planning on doing this. Is it okay? That's sufficient at that point. But beyond that point, where like the model is trained and, we're thinking about like how it will be delivered and all that stuff. Yeah, of course, from that. But yeah, these first parts, even they don't need to be like there all the time, but just keep them in the loop, and usually it works. Yeah.
But it's a challenge because there is no real university program in that field, and it's in construction. So.
And also something that I realized with time also is that like 3 years ago when I started, I needed to be there a lot because that I didn't know how other people's like how they were working. We didn't have like necessarily a defined and clear process in place. But nowadays it's okay if I'm not there like all the time at the beginning, because I know how the team is working. We kind of know each other right now, and we know, what's going on. And usually we just talk 5 minutes and like, is it like that other project, or are we going like that route? And oh yeah, okay, then I know pretty much what's going on, and it's okay if I'm not like that much involved.
And the team know what they have to do to be sure that you will be happy at the end of the project. So
they know that right now, huh? Do they?
Yes. Yes. Yeah, so it's a continuous learning and
Yes.
yes, and increasing in maturity of the team also.
Yeah.
Yes.
Oh, Véronique.
Véronique.
Yes, thank you very much. So following Gabrielle's question and Sarah's comments, since there's no real, well, we don't have enough specialists in MLOps in company. Okay, it's a general problem. Okay. So, and since there's no formal or official training in MLOps, we often have to hire them and then train them, or or let them learn by themselves, but in the company. So what kind of skills should we be looking for? Since we know there's no formal training, so what are the skills we should be looking for to hire someone who will be able to learn and do this job?
Yeah, that's a tough one. Merci, Véronique. Merci. I know, but it's a very good one. It's a very good one. I don't think I have a clear answer about that, because I think it's more about the mindset and how the person is thinking than really like a background, a specific background or specific, jobs that they've done in the past. It's really, I think at that level, I would say that the team needs to be part of the interviewing process, or, just to, because HR people might not know what to look for, and it's hard to tell them what to look for, because sometimes it's just like while you're talking and then you can sense that type of, like, is it the right type of person? Basically I would say you need someone who is like a lot of perseverance first. You need to be like hard-headed. You need to never let go of a problem. You need to thrive on problems first, because there will be plenty of these. So you need to have like that mindset of liking to like solve problems, and having almost that, I would say, hacker mindset, meaning that, not hacker in, the criminal sense of the word, but really just being the kind of person who's, is okay with, lifting the hood and, okay, what's there? If I poke there, what does it do? And okay, it's not working if I do that, because sometimes, there's no pre-written solution and you have to learn by yourself on the spot, but you need to have the right mindset to do that. And that's also true for the fact that, that person won't necessarily be from a data science background. So that person needs to be curious and try to understand, why isn't the solution working? Okay, the code is working, so it's probably like from the data science part of the project. So you need to have like that curiosity and perseverance in solving problems, and that mindset that, maybe the solution is not available anywhere. You'll have to find it by yourself and, work with it. So I think these traits are highly valuable in MLOps and DevOps also, but in MLOps in particular. And I don't think that there's a particular curriculum that, guarantees that.
You're a great example of that, because you did some training, but you learned the most of your knowledge in that field by yourself, huh?
Yeah, trial by fire. Yeah, it's yeah, that's what it is.
Yeah.
But yeah, to be able to do it, you need a certain mindset, and I think that would be like, if you're looking to hire people, that would be your main focus, looking for that mindset. How do you go about doing that? I don't know. I'm not an HR person, but that would be, I think that would be the way to go about it.
Thank you, Sébastien. I knew it was not an easy question. Thank you very much. So if I summarize, we're looking for people with a lot of curiosity and perseverance. That's what we're looking for.
And that I think that's also very important. Someone who's, willing to get her hands dirty. Like I said, the solution is not always in the documentation. When there's documentation, it's not always there. So you need to have like that, I would say, autonomy. You need to be like, but sometimes you just need to bootstrap yourself into that solution, into that thing that you need to do, and nobody's there to help you answer your question. So you need to be highly autonomous in that way, and not being afraid to poke and break things and fix things. And you need to get your hands dirty, and you need that mindset. If you're looking at a person who's afraid to make mistakes, that's a no-go for me. You will make mistakes all the time, every day. I still do all the time. And, when it happens, I'm kind of happy because I'm learning something new. So I'm like, okay, didn't see that one coming, Of course, it's not fun, but it's part of it. And you have to be comfortable being uncomfortable most of the time.
Yeah. And Emilia had another point, interesting point about business strategic mindset.
Yes.
Yes.
I would leave that part to you. I would leave you to answer that. But yeah, again, even from my perspective, it's always easier for me to deliver like good architecture if I know exactly what the business goal is. If the business goal is not clear for me, I always have that doubt in mind. And now I say it out loud, I'm not sure I understand the business goal perfectly. So what I'm proposing right now may not be like the optimal solution. If we can get through that again, that discussion of the business goal, then I might feel, confident in what I'm proposing. But yeah, it's super, 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 super important. Yeah.
I have stopped the documentary.
Yeah.
I think we're pretty much right on time.
Yeah.
So thank you very much, Sarah and Sébastien, for this wonderful presentation. And thanks everyone for your participation. I wish you all a good afternoon, and I hope to see you in our next Women in AI event.
And great success to the new chapter.
Yay,
Quebec
yes.
City chapter. Yes. So, it's the launching conference. Yeah.
Yes, thank you.
Thank you.
Thank you.